when you guys are doing the quadratic formula, you just have to make sure that you're plugging it in right. In this problem, A equals 2, B equals 7, and then C equals 3. Now, I was walking around checking people's work, and it looks like some people remember that when we did this back in chapter, I think it was like chapter 3 or something, we started off with the b squared minus 4ac part. We figured that out first. So you put in the 7, and you put in the 2 and the 3, and then you get, when you type this in the calculator, you get 25. So back in chapter 3, after we did this, I asked you, how many answers is this going to give us? If it's positive, it's 2. If it's negative, it's no real solution, so they'll have eyes on them. And if it was 0, you would only get 1. So this means we're going to get 2 answers out of this thing. So then what we did after that was we did the rest of the formula. So the rest of the formula says negative, and then we put in the b, so we have a 7 right here. And then we put plus or minus the radical, and then we take that 25 that we just found and we put it inside of there. And then on the bottom we put 2 times a, which a is 2. So I'm going to go up to the top up here. So we end up with negative 7 plus or minus radical 25. Once you take the square root and the number changes to a 5, you don't put the square root back on. You just leave it like that. And then the bottom is 4. If the radical is gone, that just means that you have to keep going. So you have to split this up into the 2 problems because it says plus or minus. So it's negative 7 plus 5 divided by 4, and then it's negative 7 minus 5 divided by 4. So in this problem right here, on the top, you get negative 2 over 4, which is negative 1/2. And then on the bottom, you get negative 12 over 4, which is negative 3. So the 2 answers are x equals negative 3 and x equals negative 1/2.
This is Parra. This is Parra. Okay. You can just leave them. Yeah, that's fine. That's okay. I think so. Fine.
Okay, so for today I have something really easy for you actually. Most of this is going to be review. The only thing I'm going to show you is a pattern that happens based on the type of exponent that the problem has. So we've already talked about this before, but I'm going to say it again. The degree of a problem is the highest exponent. So if you take that into consideration when you graph, you should already have an idea of what the ends are going to do. So this ties into like end behavior all the way back to chapter 1. So if you have something that has an even degree means like the highest exponent is like x squared, x to the 6, x to the 10th. Anything that has an even exponent is going to have the end behavior so that it matches. It's going to go up, up. Now the only time that's not true is if you throw a negative in front, which you guys should already know, because you know that when you put a negative in front, it's a reflection. It flips the shape over. So that's what you end up with down here. So if you have a negative in front, the ends are going to say down, down. The opposite, so instead of an even, if you have an odd, so like let's say your problem has an x to the 5th in it, or it has an x to the 3rd as its highest exponent, the left side is always going to face down, and the right side is going to face up. So same thing as the other one. If you put a negative in front, it just flips it. So it's not really a nice to know, it's kind of a need to know. There's a difference between nice to know and need to know. So I'm going to show you this because you're probably thinking, I don't need this crap because I can just do it all in the graphing calculator anyways. Well, I'm going to show you how that could actually be wrong. So you see this equation I have in the calculator. It says 2x to the 3rd plus 4x squared minus 2x minus 4. It has an odd exponent, and then you go to graph it, and this is what you see. So according to what I just showed you, if you go look back at these notes right here, if it has an odd exponent, the left side is supposed to face down, and the right side is supposed to face up. But when I look at this graph, it says up, up. Does anyone know what the problem is? What's the issue? Like, why is the graph not following the rules that I just told you? Let me ask you guys this question. Are you the only ones that use these calculators? So there's going to be people using these calculators before you, and they're going to make adjustments to their window. So this problem is x to the third. It should continue up like this, and then, whoa, I messed that up. It should come up and then come back down, because that's what the rule says about odd exponents. The reason why you can't see it is because the window's messed up. So if we were to change the viewing window into the standard window, now it follows the pattern, which is going to always happen. So that's why you need to know about these exponents. If your graph is supposed to go up, up, but you go into the calculator and it shows up, down, that means you have to open up your window so you can capture the entire shape. As far as what you need to learn for today, it's all review. So this is on the next page. You're going to notice these boxes from chapter 1 are going to come back. So you're going to have to do the roots, the domain, the range, the maximum, and the minimum. I'm going to go through and just define them real quick. So the roots, those are found on the x-axis. You can find them in the calculator too, because that's in the G-solver. The domain, those are x values. And that's from left to right. The range, these are y values. And that's from bottom to top. And the reason why they have to go that way is because we're writing interval notation, and that's supposed to be in order. A maximum goes like this, it's that point, and a minimum would be this point. Now, there's a lot of different ways that you can find roots. For example, this problem right here, you could probably factor it. What else could you do? You could probably do the PQ test like we did yesterday. You could find all the roots that way. Or you can just type it all in the calculator and put your stuff in, which is what we're going to do. So I'm going to take out this calculator. I'm going to hopefully clear this out, maybe, if this lets me. Exit. Delete. Yes. So the problem is negative x to the fourth. Where am I? Oh, and then plus x to the third. And then plus 2x squared. And because I already opened up the viewing window, I know this is the entire shape. What I told you today is if it's even, whoa, I totally missed that. My pens are off. If it's even, that means that the end behavior is going to match. It's going to go in the same direction. If it's odd, they're going to go in opposite directions. But there's also a negative in front, so that means that they have to face down. And that's what we see here. We see a graph where the left side's down and the right side's down. So that's how we know we have the entire thing. So as far as getting all of our answers, we can find the root in the G-solver. We can go here. So one of our answers is at -1. Then we have another one at 0. And we have another one at 2. I don't know why that took so long. So the roots are -1, 0, and 2. But here's the weird thing. This is an x to the fourth. It's supposed to have 4 of them. Why am I only seeing 3? Yeah, there's a double root, right? We talked about that yesterday. If you look at the graph right around the origin, it doesn't pass through the origin. It bounces off the origin and goes back up. So that means that there's a double root at the 0. So you don't have to write it twice, but you should be aware that that's where the fourth one is at. I got a secret to tell you about polynomials. If you're doing the domain, these domains are -infinity to infinity. That's why back in chapter 1 I said if you don't know what domain is, just put -infinity to infinity, because a lot of them are. The only ones that aren't are radicals and fractions. Fractions that have x on the bottom. Everything else is -infinity to infinity. Your range. The range is the lowest to the highest. We can get this information off the calculator. The lowest, it looks like it's going down forever, so the lowest would be from -infinity. Then we go up to the highest. The highest would be the maximum. So we can actually find the maximums from the G-solve button. So we go into max. The first maximum is right there. That's not the highest, though. I want the other one, so I'm going to go to the right. So the maximum is at 2.8. So the highest this goes is 2.8, and it's going to be a bracket because these don't have any white dots. So we're going to use brackets on those. The maximum, we're at it right now, so I'm going to write that down too. It's at 1.4 and 2.8. That's one of them. Oh, not 1,4. 1.4 and 2.8. And then, let's see, we also had negative 0.7, so I'll round that, and 0.4. Negative 0.7 and 0.4. Then the minimum can also be done in the calculator. So we go to minimum is F3. Bless you. The minimum is at 0, 0. And now we can just transfer this information over to the graph paper. So if it's showing us these key features, we need to make sure to include those in this graph. So I'm going to start off with the zeros. If there's one at negative 1, there's one at 0, and then there's one at 2. The maximum, so 1.4 is kind of like halfway in between 1 and 2. And then up to 2.8 is just under 3. If my stupid pens were aligned, it would be a lot nicer. And then we got negative 0.7. That's just before 1. And then 0.4 is kind of up halfway. So we got a dot right there. And so we're going to curve this like that, come back up, and then come back down. I totally missed that dot. My pens are not aligned, but whatever. Hey guys, that's about it. So you're going to have tons of time today to get some work done. All of our key features, you should still know how to find the end behavior. Remember that when it points up, it's positive infinity. If it points down, it's negative infinity. And if it says anything about rate of change or average rate of change, yeah, that's just the slope. So all you have to do is y2 minus y1 over x2 minus x1. So that's how you find average rate of change. And so that's it. That's the last lesson of the chapter. So that means next week we're going to spend a few days reviewing, and then we're going to take that test. On Monday, you're going to get test 4 back. I'm going to take a look at them again because I forgot to make sure that the computer didn't mess up when we typed them into the online test. And then you'll get those tests back on Monday for the test corrections for test 4. And that's it. So you guys got over 30 minutes to get this assignment done. And I'm going to have you do it all.